Welcome back to Autocraft Studio. In this video, I'll be presenting one of my automation projects completed during my engineering internship, a real example of turning a mechanical process into a fully automated industrial system. This is a fully automated electro-pneumatic pressing system, designed, programmed, and implemented using the LG Master-K100s PLC. It integrates electrical control, pneumatic actuation, and ladder logic to achieve precise and repeatable operation. The origin version of this machine was entirely mechanical, requiring constant manual operation. As part of the project, I reverse engineered the system, replacing the manual controls with a PLC-driven automation sequence. Now, the process is fully automated, detecting an object, clamping it securely, pressing it with controlled force, and ejecting it, all without a human intervention. Let's take a closer look at the components that make up this automated system. The process starts with the main circuit breaker, which ensures safe power distribution and protection for the entire setup. From there, wiring is organized through junction terminal blocks, keeping all electrical connections secure and easy to maintain. Airflow control is managed by 6 SMC VK300 series solenoid valves, each equipped with LED indicator that light up when the valve is energized. System control begins at the selector switch, allowing the operator to start or stop the machine, while green and red LED indicators display the current status. An essential sensor, the limit switch, detects when an object is positioned correctly for processing. The SMC MXS1275 guided actuator pushes the object into place, followed by two Festo 2020 PA cylinders that clamp it horizontally. A Festo 3220 PA cylinder applies vertical pressing, and finally a Festo DSNU 1218 PA cylinder ejects the object. At the heart of the system is the LG Master-K100s PLC. The power supply module receives 220 volts AC and delivers 24 volts DC to the control circuits. The loader port allows direct programming of the PLC. The input module receives signals from the limit switch and selector switch, while the output module sends commands to the solenoid valves and status LED. Together, these components work seamlessly to create a reliable, precise, and fully automated pressing process. The system's design began with detailed electrical schematics created in EPLAN. Here you can see the PLC wiring diagram showing the power supply module receiving 220 volts AC and providing 24 volts DC to the control components. The input and output modules are connected to the various sensors and actuators that drive the system. The next section of the diagram shows the wiring to the selector switch, limit switch, LED indicators, and the 6 solenoid valves. Each connection is clearly documented, ensuring accurate assembly and easy troubleshooting. Once the electrical design was complete, it was implemented in the control panel, where every connection follows the schematic exactly, from the power lines to the input-output device wiring. The pneumatic system was designed and tested in Festo FluidSim. The simulation includes the pusher, horizontal clamping cylinders, vertical press and ejection cylinder, each one controlled by a dedicated solenoid valve. The corresponding electrical control circuit defines how these valves are energized according to the programmed sequence. Running the simulation allows us to see the complete cycle in action, from pushing the object into position to clamping, pressing, and finally ejecting, exactly as it will operate on the real machine. The system is controlled using a ladder logic program developed in KGL-Win. In monitor mode, we can see the program running in real time, inputs and outputs highlighted as they are activated. Here, the selector switch input is detected by the PLC and represented in the ladder diagram. When this input turns on, the program energizes the output coil that drives the green indicator LED, signaling that the machine is in operation. This real-time monitoring provides instant feedback, ensuring that the control logic matches the intended operation of the hardware. This project allowed me to combine theoretical knowledge with practical implementation, from designing circuits, simulating pneumatic systems, programming PLCs, to integrating everything into a working industrial system. This project is running now really, and the next step will be adding HMI for more intuitive operation and real-time monitoring.